And thank you for coming today. Quite an honor. I'm based out of Pennsylvania, and by the end of this, I'm hoping that we basically just have another insulation option for you that's more sustainable than any other option that's on the market right now. So a little brief history on myself. My name is Dan Elderman. I've been in the insulation category. I was with Rockwool Insulation for 13 years prior to this. So the fire and acoustic, all that fun stuff, definitely is something that I'm very well versed in. I'm also a technical resource for all of you, so feel free to reach out. I'm typically pretty easy to get a hold of, I think. Thanks, Darren. And so, yeah, I'm going to go ahead and get started. So I'm going to be going over solving performance demands with wood fiber insulation. So TimberHP, that's a company that I'm with. We basically changed the name from GoLab to TimberHP, mostly because obviously we're a timber-based product or bio-based product. And the HP stands for high performance, healthy planet, and healthy people. So those are kind of the three pillars that we really want to we strive upon, and really trying to get our product into the market to really, at the end of the day, sequester carbon, but also make sure that the products are very healthy for the installers that are using it and the occupants of the homes. So this is just a quick, brief video on kind of our mission story of why we're doing what we're doing.
You know, our family's always been in the sawmill business. We love the way of life, and it's hard work, but there's nothing wrong with hard work. If you lived on an island, probably you'd be in fishing, or if you lived in the desert, you'd be doing something with sand. But we live in a sea of trees, and it's only natural that we make a living from the woods and off the land. We make square boards, rectangular boards, out of round logs, so we make a lot of chips. And those all go to the paper companies. The paper industry has been suffering. When we lose those paper companies, we lose the market for those chips. And that means that the whole wood industry in Maine is suffering because we need markets for a low-grade wood.
Buildings account for about 40% of the total carbon emissions globally. Buildings have to save energy to address climate change. You know, one of the advantages of having a design build company and not just being an architect is that you get feedback every day about the buildings you're building, the materials you're using, and how it's going. It really depends on the insulation product you use as to how effective you're going to be in actually saving carbon. We've always had complaints about insulation. It's itchy, it's scratchy. We make all these microplastic beads when we cut it. They have, you know, kind of scratchy respiratory issues after using it. They're using full respirators and Tyvek suits in many cases to install it. We knew there was a problem. It takes about 8 years of energy savings, carbon savings in emissions to pay for the carbon debt of the original insulation you installed when you're using conventional insulation. Quite frankly, we don't have 8 years to wait.
You just pick it up, you know what it is. You know that it's wood fiber. You know, I wanted to know more about the product and how it performed, and Matt said, you know, best in class acoustics, best in class vapor permeability.
So we knew about wood fiber insulation from Europe. We're talking about a material that's natural, it's 95% wood. There's no added toxins.
And I said, you know, when are we going to use it? And he said, never, because it's not manufactured here and shipping it is not, you know, a business model that works. And I just couldn't really accept that. I couldn't understand why this product was not manufactured in North America, where we have better wood resources than they do in Europe, and we have a building style that fits this type of insulation better than what they have there.
I lived in Maine all my life, and you drive around Maine, any town you go through almost, there's some buildings sitting there that something used to be there. Most people don't realize what a tremendous economic engine a paper mill is. You know, they employ hundreds of people.
The people who worked at the UPM paper plant for so many years, their intellect, their capability, their passion for forest products for the community, losing that out of your community, a small community, is absolutely devastating. When we're up at full production, we're employing more than 100 people in that community. Well, those are 100 good-paying jobs in a community that is a couple thousand people. That has a multiplier effect that is massive for the overall community, and it really is the identity of a lot of these communities in Maine. We need working forests in order to grow the forest, in order to keep them viable. When it comes to Madison, it's right in the heart of the wood basket for Maine. We have a huge market in the Northeast for insulation. It's the biggest insulation market in the entire United States. We have a lot of existing housing that needs to be upgraded.
The key to addressing the climate crisis with buildings is to not only save energy in the future, but also do it with insulation products that come to the job site with a negative carbon footprint or that are carbon storing. And wood fiber insulation is the only scalable option that can do that. You know, it's easy to handle, it's very familiar, it's not scratchy. They can cut it easily. The byproduct of the cutting is sawdust. With wood fiber, you never have that impermeable layer, and like Gore-Tex, it allows that moisture to move through the assembly, not causing any mildew or rot in that wall assembly. And so the game-changing aspect of wood fiber insulation is that not only does it have the favorable building performance attributes, but it's also cost competitive. And that's really key to the success of any insulation, is that it has to be cost competitive with the alternates in the market, but also bring the building science performances that we need.
It is a dynamic industry, and we have to keep changing to keep up with the times. Every time you add a little more value, you leave some of the competition behind. Well, I see the same thing with GoLab. They're going to make at least 3 different products there. You know, that's adding value. Wherever there's timber, there's sawmills. Wherever there's sawmills, there are residuals that they need to get rid of. And everybody I know that burns their chips would rather sell their chips to somebody like a GoLab or a paper company. Once the reputation gets out there and what a great product this is, and people learn how to use it, I think it will go all over the country.
So one of the really cool things is we were doing the same training up in upstate New York. Sorry, it gets a little loud. We were doing a training up in upstate New York, and the lumberyard that we were at actually said that they buy their lumber from Robbins Lumber, and now they're also buying the insulation, so they're literally using almost the entire tree. The only part of the tree that's not used is the bark in our current facility. So this is our current facility. We're sitting on the Kennebec River, so it's absolutely beautiful. If anybody ever wants to go to Maine, we do have factory tours as well. It's quite an experience when you're there. It's in literally the wood basket of Maine. When I go, it's very humbling for myself going in there with this logo, and actually going into the town, and the town is extremely welcoming of us, which is a big part too. So we're basically, and you could see these 2 little, they're actually like a Dyson vacuum cleaner, and it'll go through the process, but that's like a drying chamber. We do use hydroelectricity. So 99% of the factory is actually run on hydroelectric power. So that's another part. Currently, our EPDs, we need 1 year of production time to get like a good sense of what those are. What's really cool for me, and something that I was kind of new to, because my background was always the denser, the more material of a product, the higher the embodied carbon. It's actually the opposite with wood fiber products. So the more material that we're using, the more wood chips that we're using, actually the lower carbon negative that it is. So these are the products that we are offering. Timber Fill, you can see the bags right here. This is a blow-in, loose fill, dense pack product. Timber Bat, this is a very similar to like a mineral bat in the way that it kind of looks. It's just a little more golden. And then Timber Board, we're looking at Q4, December of Q4 actually now, instead of the Q3 that's up there, of when that release date is. So we actually, for that piece of equipment, we brought the equipment over from Germany, And so we're getting some assistance on rebuilding that machine right now. So it's all built, and we just are missing one part that was left in Germany. So we have to ship that over now. It was basically like Barnyard Builders, if anybody's familiar with that show, how it basically like we numbered and labeled every single joint and intersection, shipped it over. The machine actually cost us about $2 million to buy and $4 million to ship. So just like a lot of these insulation products, sometimes the shipping gets a little expensive. And
All the best stuff comes from Germany, though, right?
yeah, exactly. German engineering. But the Batline is a very nice run. The other thing I'm going to say with when it comes to like product sourcing, we have 3 separate product lines. That's something very new to me, coming from a mineral background. So we actually have a line just for timber fill, a line just for timber bat, and a line just for timberboard, and we could run all 3 lines at once. So our production capacity is actually much higher than even a mineral facility. This is an AIA, so if you did or did not, just make sure your AIA number is down there. I'm just going to take a picture at the end, and I'll submit all the AIA credits. And basically, I always like versus this one. I like this one. The course outline, we're going to be talking about just the current insulation market as a whole. What is wood fiber insulation? We're going to talk some code compliance, some codes and standards. And then we're going to go through some, real world things on the embodied carbon and wood fiber insulation. So the current insulation market, this is actually a cool project up in the College of the Atlantic up in Maine. It was European board, obviously, but also used our timber fill product in that. So in the U.S., it's a $100 billion insulation market right now. So it's a massive market. Fiberglass holds most of that. It's 56% of the market is just fiberglass. Foams and plastics are about 35%. Mineral wool is 4.7%, and then all the others. So we're still new to the North American market. If anybody has checked the news or anything lately or got our newsletter, yesterday we announced that we do have a strategic partnership with Saint-Gobain, which is the same company as CertainTeed. So the global leader and the biggest company in the building material world. So they're going to help us with our codes and standards, getting more UL listings, more, ASTM standard testing, like a lot of just help with that. And they're also going to be distributing in the Canadian market as well. So that was some big news. So little current insulation options that we have. Fiberglass developed back in the 1930s. There's actually some fun stories when people first started insulating homes in general. Painters won't actually paint the houses because they had something called vapor drive, and it would pop the paint off the exterior of the house. So we'll get into a little bit more of that also with like vapor control and different climates and all that. Obviously, this is a cold climate. So basically, there's an increasing building codes as well, and that's one of the biggest challenges right now with the current insulation market and why we're seeing so many shortages, because now code is actually driving it up. So even though that there's basically the same amount of buildings, if you look, kind of getting produced year over year, but when the insulation packages are elevated, especially with the continuous insulation, that's going to put a bigger demand of insulation products out there. Now, if we're not thinking about sustainability when we're looking at these insulation products, it could take a very long time to make sure that we're still carbon neutral right out of the gate with those insulation products. And then, there really hasn't been any new updates in insulation products out there. And when you start looking at some of the practices that we're currently doing, if you need a hazmat suit to be installing a product, maybe it's not the right product. I understand there's a lot of positivity with like air sealing and other things with like closed cell spray foam. But when there's other options out there to build differently, and one thing that I talk about a lot is vapor open airtight, allowing houses to still dry out properly without trapping moisture. Up here, I remember vacationing. I grew up in Michigan, and I remember vacationing in Minnesota, upstate, Upper Peninsula, Michigan. And in the summer months, nobody had air conditionings. Now everybody has an air conditioner. So that's something else that's changing. It's just, and I know this year in Minnesota, we changed some climate zones. Some climate zone 7 counties are now climate zone 6. So that's just showing that it is getting warmer. And by having no vapor barriers in a system is actually a very beneficial thing for the drying potential and durability of that wall assembly. Then introducing wood fiber, you could see night and day difference. Now, it was a cold day, which is why that's Scott Dion, why he's wearing a sweatshirt. But you could see no gloves. It's not an itchy product. It's not an irritating product. It's just simply wood fiber. When we start looking at the current European market, it's $1 billion industry over there. And they're building most of their homes. 24% are wood frame, and the rest are actually all CMU, so concrete masonry units. So a lot of concrete over there. It is also a price premium, just like similar to this market, just from shipping it. But as we kind of get in, we do have some future plans for growth outside of the state of Maine as well. And then this is just a quick video. There are 15 manufacturing facilities of wood fiber insulation. These are them right here. And they all make kind of different products. I'm not sure about volume on this one.
Turn off your laptop at all?
Let me back out. It's really just like upbeat music. So just like put a nice tune in your head. But basically, you can see, the way that they're working with the product. A lot of off-site construction, modular homes, whatever you want to call it. They are putting like timber board or a board product on the exterior without sheathing. So that's something else. You would definitely want to run it by a structural engineer, but it is something very possible. And that's going to be a very highly vapor open system as well. You could see, they make the blowing, and then you also have Gutex, which is the board, and that's a tongue and groove panel. We are going to start with the square edge and then eventually get into a tongue and groove also. The nice thing about a tongue and groove is you're not going to need to tape the seams if you're using that as a WRB, as your primary air barrier. So very neat stuff, and you can see some of the cool tools that they get to use over there. The bat product, one of the first early kind of product development things that I was in charge of was making sure that our bat is easy to cut with just a regular serrated knife. So just something very simple. The European bat, the big difference is actually the bicomponent product, and I'll go through what that is. But basically the bicomponent makes it a little more challenging to cut the European product than our product here. It's a much more forgiving product than the European market. Well, yeah, we're going to buy a truckload and we'll do that. So when you start looking at wood fiber in North America, I remember hearing about wood fiber probably about 5 years ago, and I was hesitant coming from the mineral wool category. And when you start thinking about it, wood is a very abundant resource in North America. 99% of our homes are built out of wood, untreated wood. So if anything, this is actually going to be more durable than the wood stud, the shell of the house, the structure of the house. And it just really makes sense for all above grade applications or not in contact with the dirt. That's our only one rule, is we don't want to bury this product. End of the day, it is still just a regular wood-based product. And because they're not womanizing any lumber or trees, we're not going to be using any of that to make pressure-treated timber board. And it is just wood. So there's no toxins, 95% wood. We do add a little bit of a liquid borate, which is a natural salt. It's in toothpaste. It's in laundry detergent. It's also in borax, which is an insecticide that you sprinkle around the outside of your house. We were just on this old house, and when I was talking to Kevin O'Connor, when we were kind of going over the material, and I brought up borate, he's like, oh, I use that every year. It's great. It just sprinkle it around, and it's a good natural insecticide. It can be handled without wearing gloves, long sleeves, chemical respirators. We do still recommend, a dust mask and eye protection for overhead. It's still similar to, cutting lumber. When we're actually producing it, what we're doing, we're taking the round logs. We're not cutting down trees for this. We're working with like Hancock lumber, Robbins lumber. They're milling dimensional lumber. So rectangular pieces of wood out of a round tree. They debark it first, and then they create wood chips. So they're chipping all the waste wood. For many years, when the paper industry was on a decline, they were having to landfill it or burn it. So now they're able to sell it to us at a very low price. It's like $150 a ton of wood chips. So it's very cheap up in the state of Maine. So that's where it gets more of an economical product also.
Who pays for the shipping?
Shipping the wood chips?
On it, like, how does that fit in there? Who pays for it?
For the wood chips? Yeah. So the wood chips, we pay for the shipping. But literally, it's right up the road. When you come to the mill, you'll see the logs are going up past, and then the wood chips are coming back down. So, yeah, it's pretty cool. And then the different processes. So we basically take the wood chips, we steam them, we shred them with just big giant plates, and then we add the liquid borate. So that's something that's very different in the industry. If you heard of cellulose products with borate, they use it powdered. That's where our founder, Josh Henry, comes in. He's a material chemist from the University of Maine. So he was a professor there, and he was able to liquefy the borate so then it impregnates evenly in throughout all the fiber. And with that, you're not getting a dusty product. So the dust is going to settle out very quickly. If you've ever installed borate cellulose, you'll find that there's just like a cloud of dust that lingers for a very long time. It gives you like a tinny taste in your mouth. That's from what I hear. But basically, and I'll pass this around, but that's our blowing product. And again, that's just going to be the borate, shredded wood chips and borate. We also get to use a lot less borate than cellulose. So it's typically about 50% less because it actually absorbs into the fiber. I always say a lot, we're using a pre-cellulose cellulose because it's before that cellulose turns into a paper product, turns into cardboard, turns into anything else. So we're also species specific right now in our production. We're only using pine, spruce, and fir, so all softwood materials. We had hemlock early on, and we found that it was a more tangly fiber, so we found that the blowing machines were getting clogged up a little bit more if it was a smaller machine.
Does that product work for dense packing or
Yep.
something similar?
It does, and actually it'll dense pack at a lower density than cellulose because the fibers will interlock.
Yeah, it just naturally stays in that.
Yes. So, and right in front of you is our coverage chart. So this basically has like all the coverages for your dense pack down here and then your attic coverages up here. Yeah, we just blew in a 700 square foot attic at R60 in Iowa yesterday, and it took 65 bags. So I would never say R100's too much. So we did have a question on, we do a webinar every month, and we had a question come in about filling a 40-inch truss. And I was like, that's an R160. That it's probably excessive, and I'd rather see a vent. He was trying to do an unvented system. It was a roof. And I was like, you need a vent, and you don't need an R160, because then you also have to worry about drywall and all that. I was like looking at that again. So basically, the big difference then in the process is the bat. The bat, what we do, we actually take a binder. It's a polyester binder, 2%, and we basically have the fibers in there, and we utilize hydric buffering and redistribution to actually melt it evenly throughout the product. Now, our highest temperature in the facility is this process. It's 150 degrees Celsius. So versus other products that are melting at much higher temperatures, and it is all electric power for that. The difference is with the board, we're using a PDMI binder that's essentially Gorilla Glue, and then we push steam through it because it's vapor permeable, so steam will go right through that, and then it cures that the Gorilla Glue, the PDMI binder. And then this is kind of where we're pulling our wood from. So they are all FSC or STI or dual certified forests, which basically means that they're sustainably harvested and everything. When you start looking at the total country for this, you can see there is a lot of areas that we could expand into. Noting, that northern Minnesota, Wisconsin area, and I guarantee you there's paper mills up there that we could actually take over and convert over into a wood fiber. It's very easy to do the conversion. Obviously, it just costs money. So we're trying to, do a lot with the main location first, but we already have plans and have received the largest grants of the U.S. Forestry Division that any other company, private entity has received, because they're looking at Oregon and Washington State. And over there, we're going to be helping with deforestation to reduce the chances of wildfire. So a lot of the branches, the smaller twigs, things like that. So it will be a completely different process there than it is up in Maine. But, wildfire is something that we all want to partake in, helping out wherever we can. And then you can see the southeast as well is another big area. And we did run some southern yellow pine there through our machines just to see if it would even work. And it does. It works great. So some of the features and benefits, I think we've been talking about carbon a little bit now. So carbon storing, and that's just the nature of trees in general. And by harnessing it and locking it into your walls, it's mold and mildew resistant, and that's another activity of the borate. So it's not going to trap moisture, but it's also, if it does get wet, and I've had a sample in my backyard now for six months or 8 months now, and it just gets wet and dries out, wet, dry out, no mold or mildew at all on the actual bat itself, which is really cool.
Is that because of the borate? Or?
That's mostly the borate, yeah. Yep.
And this PBM, I'm sorry to interrupt, whatever it is, but I think paraffin is used in.
We also use 0.5% paraffin.
What's the difference between those things?
So PDMI is the binder. Paraffin is the thing that makes it hydrophobic. So
We use that too.
we use both. Yeah, the paraffin is coated on all the fibers also. So when you're cutting it, you're not like removing the paraffin. It's still going to be hydrophobic even on the end. So, and that's because it's a rigid exterior board. We want to make sure that it's hydrophobic so it sheds more of that water. Highly recyclable. We do have plans also, like if you're on a job site, you have some scrap 2x4s, we could use that. That's typically pine, spruce, or fir. So it's all able to be recycled. Obviously, nails will completely ruin our machine, so we won't be accepting any nails. And it's non-toxic, and it is actually, believe it or not, a Class A flame spread. Again, with the liquid borate, it's going to protect it. Now, if you're burning off the borate, because it will actually help self-extinguish the flame, you don't want to reuse any pieces that got burned. But that's with all insulation products. I always say if your house is on fire, the biggest issue is your house is on fire. Get out. But this will give you more time, and there's no melting temperature for any of our products, whereas all other insulations will have a melting temperature. Foams and plastics between 300 and 400 degrees, fiberglass 900 to 1200 degrees, not paper-faced, and mineral wool is about 2000 degrees. So this, we could take MAP gas to it, which burns at 3600 degrees. I may or may not have done this. And you could actually put it right on the bat, and it's gonna smoke. You get a little bit of a gray smoke, but that's it. It's never gonna hold the flame, and it's not gonna melt. Yep. So it's 0 flame spread, 5 smoke development. Yeah. And I'm not sure if I have that in here, the ASTM E84 test. The AIA is slightly different than my normal presentation. But market position, basically anything above grade. You could also use it in your basement, wherever you use like a fiberglass bat. That's going to get wet and lose its shape, whereas this product, if it gets wet, it's going to hold its shape and then dry out. If you do have a bulk water leak, definitely fix the water leak. That's an issue. And right now we're kind of focused on that kind of type 3 to type 5 construction, which is your wood frame construction. You can use us in steel frame as well. We do have some fire engineering reports that showcase an 80% load-bearing wall with steel studs, 1 hour and 2 hour fire ratings. And then with wood stud, it's 100% load bearing. So obviously if it's a non-load bearing wall, it's a shoe in for those. But even load bearing, you could actually use this for a fire and sound wall insulation. So the loose fill, so pretty much some of the perks of this product, obviously the ease of use. You know, you hire an insulation contractor, they blow it up in your attic, weatherization contractors, you know, or the dense pack. And that's actually something that I'm pretty new to, but after actually installing it myself in like this old house and other projects, it's quite nice because it will completely detail a lot of those areas that are really hard to cut the bat around. You could really just net it with InsulWeb, and then basically just stick your needle in there and dense pack it to a 3-pound density. Another nice benefit and something that I do have to bring up is the fact that you do want to use InsulWeb even before you put up your vapor retarder. So if you're using like a smart membrane, like an Intello, a Sega, a Certainteed smart membrane, those don't allow air out. So when you're pumping a product in, it's going to slow down that production. You could use relief holes, but then you're taping up your air barrier. And the issue with that is then you have a bunch of holes and costly tape. And if you forget a hole, then you cut your air barrier. So that's where the InsulWeb helps first. And then you would come back with the membrane that you choose. It's an R 3.8 per inch. Again, on the coverage chart, you can kind of see what that R value is in an attic or in the walls. Then our bat insulation. This is something that you could use in any cavity. We do have wood stud and steel stud products. So, and I'll actually pass this around. You might get a little dust. It's just sawdust, but it's not itchy or anything. We're offering a 3-inch acoustic bat, then a 3.5-inch R14, a 5.5-inch R22, and eventually it will be an R30. So probably about 7.5 inches for that one. We're R4 per inch on the bat. Again, factory setting, we could just really mess around with the densities a lot more. We are a much higher density than other products, so that's about a 2.8 density. And what that means is you get a lot less convective looping and other things happening in your wall. Just a tighter fit in that wall cavity. And then some incredible with sound. Yeah. I think I do talk a little bit about sound in this one, in the codes. And then insulation for all seasons. So despite what people think, we also need to cool our houses or keep the heat out of our houses. And the thermal capacity of this product is by far the best on the market right now. When we start looking at, this is just like a little thermal lag test. So how long it takes for heat to move through this product. You can see the R values. It's R6, per inch versus R4 or R5, depending on other products. But when you start looking at the time and the temperature, we'll get a little bigger on this. So you'll see after 10 minutes, you can see the temperature. There's a little diode in here, and you can see the temperature difference. So it's going to store a lot more heat. So here, when it's hot in the summer, it typically cools off in the evening time. That heat will actually get stored and then get released when it gets cooler outside. So that heat never actually makes it into the building. If anybody's ever lived in a CMU build, old stone house or big log cabin, I guess would be probably more around here, that's going to take a long time for the heat to change within a house. And that's really not because of R value, that's because of thermal lag. Then the continuous board. Again, we're going to have the square edge and we're going to have a tongue and groove. We do have, it's going to be early on, it's going to be 4x8 sheets, starting at 1 inch and going up to 9.25 inches. So it does get heavy at those thicknesses. So we're kind of primarily looking at those real thick boards more for the modular industry where they have cranes moving them, because a 9-inch board will be 300 pounds. 5.5 inch is 145 pounds. It is a 15 PSI product also. If you look at the PSI of other products, they're, range in depending on which ones you're using, foam, mineral wool. But you could actually put this product down on a floor, put one layer of like 3/4 inch plywood on top, and you could actually walk on that. So you could use it as kind of like a subfloor material. It's also great with sound in between floors, or even do like a concreteless slab if you're doing like a conditioned crawl space or basement. For anything that you're going to be putting a lot of traffic on, like a basement, I recommend 2 layers of 3/4 inch plywood just to cross laminate those, so then it doesn't move as much.
But that weight basically indicates the thermal mass too, right?
That's correct.
I think you'll be able to use the board material instead of plywood.
On probably not. You would still need to hold it down somehow, and the plywood effectively would be kind of what pins it all down to the ground. So,
Or for walls, you probably still have to do strapping or something for your.
Oh, for shear, you definitely, if you're getting rid of plywood or OSB on the outside, you either need to use a little bit on the corners or the shear, the metal strapping.
Sure.
So either of those options do work.
And when you guys do get into the panel products, are you guys looking at doing any sort of design on like fastening schedules or anything like that?
Oh yeah.
Okay.
100%.
That's because that for me on the build side, that's always
Yep.
a challenge when somebody starts questioning what the fastener schedule is. You get a local engineer and then you end up with massive overkill and
Yeah. Yeah, for the time being, we're going to say 5 per board, pin the corners and the middle, and then we always recommend furring strips. And then based on your weight on your cladding, they have some RDH reports that will actually tell you what that nailing schedule vertically is. So typically like 8 to 12 inches for like a lightweight or a heavyweight cladding. And then as you go, if you're doing just like vinyl, you could do 20 inch, 16 to 20 inch between those vertical. And when you start talking about the thicker boards, that's when obviously we'll need to take a look at it, but, and because especially also if you're getting like 17-inch long screws, they're expensive. So you don't want to be like every 8 inches when really you only need one every 16 inches. So yeah, I've done that before. So
yeah, it's lockers. I think 14 is about our max.
Yeah.
I don't think you exactly said this, but you could make SIP panels out of the boards and the insulation, but it wouldn't have wouldn't be a structural panel.
Well, if it sips, then it would be,
No,
because
using your boards.
if it's only our board,
Yeah. then it would
right
be
now, because
structural.
we haven't produced it yet, we can't say anything about
But,
that.
I mean, is that your expectation? Is that
It-
have to be doing that?
It would be, yes. Yeah. It would be great to use it as your structure as well. Like replacement for like a zip R kind of board.
What's your release thought for the different counts and displaying the visual?
Yeah. So we're going to start with like 1 inch to 4 inch, every probably ½ inch to begin with. And then like the 5.5 and the 9.25 and 7.5 are going to be probably like a non-stock item that we could still produce even early on, but it will be full truckload quantities. And this product does ship really nicely, so meaning that it's lower cost per square foot because we could fit 30,000 square feet on a truck.
Do you envision the 1 to 4 maybe expecting to see some one of third?
December is when we're saying we're going to be shipping. Yeah. Yep. Yes. You can see the durability of the board. This was actually on a project for the College of the Atlantic for about 1.5 years, and they're using it as steps. So you can see the durability of the product is actually very high. Also, it's water. This is the hydrophobic. We do treat it with the 0.5% paraffin. And our goal is to also treat it with borate, so then it will counteract any kind of wax with a fire rating. And our goal is to have a Class A fire rated product for things like NFPA 285 and other commercial codes.
That is in the future.
Yes.
Like
Yeah.
list too.
Some folk for fit or kind of a auction line strip now, or you kind of look and well, if you're going to use this inferior product, you just do like a double layer or something.
Correct.
And kind of offset the joints.
Exactly. Yep. Yep. That's kind of what a lot of builders are going to be doing anyway, I find, because they're used to doing that with foam. Although we don't have the same shrinking and expansion of like a foam product. So, and again, that's another test that like Certainteed will help us out with dimensional stability. Then this is just talking about like this is a Class B board that was in this fire video, but you could see kind of what happens with this.
Is there a problem there?
No issue. But again, melting temperature is very low on these foams. They're still Class B products, just like ours in this one. This is the European board, and they don't treat it with the liquid borate, so it's going to be a Class B. But again, it's like a log. It's going to take a long time for it to actually burn through the product itself.
I would imagine it's like burning a pile of sawdust. It just doesn't.
Right. Or a bale of hay. If you ever, I tried doing it.
Eventually, those biodegradable. I think I saw one. Wait, which one's that last one? That one looks awesome.
That's the wood fiber board. And that's Edith. So, yeah, you could see it smolders. Again, that's a Class B, so it doesn't have any flame retardants or anything on that one. When we start talking about moisture, which is another big part with our products, wood fiber is highly vapor open. So at 1 inch, we're at a 44 perm rating, so very breathable, if depending on which code or what logic that you're in. But I always say drying potential is very high. It's also, if it does get wet, like condensation, kind of moisture inside of the wall, if the insulation does get a little damp, it's able to dry out, and it utilizes hygric buffering and redistribution, which is just a matter of getting wet here and then redistribute that moisture throughout the whole product, just like a tree does during its life. It also helps with indoor air quality because it's mold and mildew resistant. It's not going to really add, it's not going to off gas or anything else. There's no blowing agents in the product itself, so it's really going to help with the indoor air quality of the project. The big thing with this is also, and we kind of can start talking control layers. You know, obviously your number one control layer is water control. This is going to be the most important one. You don't want your house to rot. And that's going to be on the exterior of this image. So right on the outside is going to be where your primary water control is, and that's utilizing the paraffin. Then your air control layer, I always like
part of the board that's not
an extra layer you put on.
That's correct. That's the board itself.
Don't put it on backwards.
Well, the board is, you could use it either way. But the red line, you're looking at your primary air barrier. I'm a big fan of putting your primary air barrier on the exterior of the house, even in a colder climate, utilizing your WRB. Again, once we get into the tongue and groove or even the square edge with tape seams, we're still doing testing on the tapes that will work with this product. But we need to produce the product first. But I always like right there because then you have very minimal penetrations throughout the entire assembly. If you're moving your primary air barrier to the inside, it gets kind of complicated with outlet boxes and all sorts of other things. Vapor control layer, it's going to be on the interior or the warm side of the wall. Everybody up here probably, I know there's a lot of polyethylene. There's a lot of reinforced poly up here. I'm not a fan of that. If the house has air conditioning, we don't really want to be using any kind of polyethylene because now you eliminate the drying potential inward. And that's where if you do want like a belt and suspender approach, you know, I always recommend, you know, using a smart membrane. Now in the code is called the responsive vapor control. So that's a class 2 vapor retarder. When you start, and I'll go through a little bit more on vapor control. Codes and applications. So we are approved in Canada and the US market right now. We're still working on a lot of the Canadian portions, the little subtitles and everything for that, but all 3 products. When we start looking at climate zones and the codes that we're starting to look at for the IRC, the International Residential Code, I'm going to pull out climate zone 6, which is where we are. And you can see there's an R30 wall. So that's going to be R30 in a cavity. I'm already seeing, people building 2x8 wall sections, which in my opinion isn't the best way to build. And talking to some builders, they're also saying that even though it's less labor per se, you're not sending trips around the outside of the house, it is more labor because it's much heavier wall systems, and you still are leaving that sheathing out in the cold, which is always the biggest issue, which is why now in the code, it also has continuous insulation. So if you look, that 20 plus 5, that plus 5 is going to be what's needed on the exterior. And I will say 20 plus 5, when you look at the vapor control code, you still need a vapor barrier or vapor control layer on the inside of that wall because you're not keeping your sheathing warm enough to reduce condensation. Now, the wall that will work without any vapor control inside is the 2x4 wall with an R10 on the outside. And that's just really looking at your ratio of exterior and interior insulation. So you're warming the sheathing, and your heat when you're warming your house is easier to go through an R13 versus an R20.
It's not a go. Sorry, they'll never adopted the new, so we have a great history of not adopting.
Oh, yeah. No, I know. You're still on 2009 code, I think. 2012? Yeah. Well, maybe you'll adopt the 2021. Oh, right. That's right. Yeah. Yep. And then when we start talking about like the benefits of continuous insulation, it's a lot with thermal bridging. You could see in a house, you get about 25% thermal bridging. So that 2x8 wall necessarily is not going to be your best option. And that's where putting on a sweater is definitely a very important thing to do. Building enclosures, these are kind of all the different codes. I'll kind of go through this a little quicker. Vapor control codes, when we start looking at this, you can see the perm rating of all these different materials down here. All your foams at about 1 inch are going to be a vapor barrier. Now, if you're only putting 1 inch of foam in this climate on the exterior, you just removed any drying potential outward. When you start utilizing continuous insulation that's vapor permeable, you still are able to dry outward, even if you only have 1 inch, 2 inch, 3 inch, whatever you want. So it basically is, I call it a release valve for your wall. You still really have that drying potential. Now, right now in the code, I'm going to go climate zone 6. The big thing to remove to go into a class 3 vapor barrier, which is just 2 coats of latex paint on your drywall, the biggest thing is ventilated rain screen systems. So that's going to allow that vapor to move through the wall and dry somewhere. The other thing is using like an R7.5 over a 2x4 wall, or an R11.25 over a 2x6 wall. So you'll see that it's kind of looks backwards from the code, the IRC code. So again, not going to be using any more polyethylene plastic for vapor barriers.
That's something that we'll have to educate inspectors on.
Yeah, exactly.
I struggle.
Yeah,
Well, poly.
So, and this is something that is right in the code. I want to say it's like 7. Yeah, with the EPS on the outside, and that's similar to this too, is you start putting that up. Now, one thing I'm seeing up here is people are putting that R5 outside, but still with their polyethylene vapor barrier, and you have a trap system there. And now they're like, well, yeah, and they're finding their wall cannot dry, and this is a very unforgiving climate.
Take 1 to 5 years, and if you're lucky, it goes down the building warranty period.
Exactly, yeah. Oh, and then this is our smoke development NFPA or ASTM E84 tunnel test. But this is basically what the test looks like. They put a flame on one end of a piece of product, and they basically light it and see how far it travels through the tunnel. And then they also measure with the spectrophotometer the smoke development. So we're a 0 and a 5. We're a class A for our bat and our fill product. And then NFPA 285, this is a question I get a lot. Our bat, technically, and we're going to be doing more testing on it as like a cavity for like a Z-girt system or the rail systems that are for commercial buildings. So we'll get that tested out, and hopefully it will just fly right through NFPA 285. But in the meantime, basically you would need to go, is it foam, plastic, or combustible? And then you'd have to basically do different tests for NFPA 285, get it engineered into the system. But again, the bat is not right now approved for that application. We would actually increase the density a little bit too. And the board would obviously, yeah, board would be first. Yeah. But a lot of times board strap through installs, we're not seeing that on buildings above 60 feet high, which is where that code kicks in. So a lot of times they're using the rail systems with the cavity insulation, like cavity rock. And then these are kind of the build types that we're looking at getting more involved in. So type 3 to type 5. So going to be more your wood structures, non-combustible, exterior walls and whatnot. When you look at embodied carbon, I'm going to just, for time-wise, I know we're running a little bit behind, or actually I'm still on East Coast time here. So the big thing, and you heard Matt say it in the video, but buildings actually use 40% of the CO2 getting pushed into the atmosphere right now. So that's a big number, even less than transportation or automobiles. And the other part that's kind of creeping up that we're noticing is the embodied carbon of the materials themselves in these builds. So if there's an easy way to switch over from one product to another, you could easily reduce your carbon. And another study that we're looking at doing is for steel stud builds, to actually have it so this product, which is carbon negative with steel stud, would actually negate that and make it a carbon neutral building. Even still with the steel and even potentially the concrete that's used in those builds. And then this is kind of just the future, as we're seeing more and more insulation being adopted by the codes. We're going to also see that building material carbon going up as more materials are being used, as operational costs are going to kind of level off, because now we're super insulating the buildings to a point where that's going to drop off. So you might actually reduce in the amount of operational energy used in the buildings with these, but you're going to see higher insulation count. So by simply just changing your insulation material over, it's going to reduce that CO2 output. When you start looking at the biggest things for CO2 in a building, number one is definitely concrete. Insulation, because it's just so much of it, is number two in every single build. So it's very easy to swap that over. Then this is just the figures. Like I said, this is kind of a number from the European product right now. We're going to have our own very shortly too. And then how does that kind of work? Why is it carbon negative? And basically it's from over the life of the tree, it's absorbing the CO2. So it's helping to absorb that. And then when the tree gets cut down and then left to decompose, that CO2 basically goes back into the atmosphere. Whereas by making it into a product, it's basically getting trapped into that wall system for the life of the home. When we start looking at like an actual model of this is just a 1,500 square foot passive house. Just the bad insulation alone, if you're comparing it with like a mineral wool product, you're looking at 5,600 pounds of CO2 savings. What does that mean? It's basically equivalent to the emissions of driving 7,100 miles in your car. So it's quite a bit. When we add a board product as well, and what I said earlier about the board actually being more carbon negative, whereas other products are going to be higher, we're now 19,000 pounds of CO2, which is equivalent to driving a vehicle 23,500 miles. And that's a non-electric vehicle, I might add. It would be higher. It's almost double that. So combined, we're looking at saving the emissions for one car driving for 2.5 years. So that's quite a bit of carbon that we're actually saving there. One other really nice thing, obviously we do have added support. So myself included with TimberHP, help with any of your designs. We could run it through. I've been doing WUFI analyses for many, many years, so I kind of know what is needed on the outside and the inside for condensation control. That's the biggest thing for that. So I know up in this market, typically probably an R10 or R12 on the outside is going to be the best thing for a 2x6 wall. And then also eliminating that vapor barrier as well and just going into like a class 2. We could set up virtual calls. I could do, we obviously have this lunch and learn right now, and also install support. So, I mean, with technology, I do a lot of FaceTime calls with builders that are actually detailing a window, or, we do have, with Matt Damon, we have Matt Damon. He's our field technician. He's not the Matt Damon, but he's a Matt Damon. But he basically he'll be able to work with your installation contractor to dial in the machine, increase efficiency, and just help out with any machine out there. So he's also a really good resource. I could connect you with him, or just connect me with your installation contractor with the fill product. Yeah, we have another Ben Affleck. I'm hiring him in Ohio. He's not the Ben Affleck, though. And then product sourcing, obviously this is Cloud9. So, Cloud9 is going to distribute all three of these products. So they're your source in this market. Installer trainings, we do have monthly webinars also. Every month I get together typically with like 2 or 3 other builders and architects, and we just have a conversation about whatever it might be. This past month, we did like vaporizing myths of vapor barriers. We did one on conditioned crawl spaces, attics, vented systems versus unvented systems, and how you want to build those. So it's just kind of like in detail, but it's a round table, so it's more of a discussion with any kind of live Q&A as well. As you could also see with our building science detail that are here, we worked with Joe Stiebrick on a guide for builders, which is available to everybody. This is going to be mostly residential, but you can kind of see that, some of the details are very, very detailed. So basically, this is a slabless slab on grade, or concreteless slab on grade, not concrete slab on grade, concreteless slab in a crawl space that you could kind of use right from there. It is climate specific. So don't go looking at the climate zone 1 and 2 and think you could put a vapor diffusion port in a roof in this climate, because you can't. That's by code. You can only, anyway. You don't need to hear. That guide is out. Yeah. So if you go to our website on like a regular computer, you'll see a banner at the bottom, and you just click on that and it'll pop up, and then you put in your information. It's an 80-page guide, and it's informational too. It kind of talks about vapor control. It starts with what is a building. So it really dives into a lot of the really good information. And we wrote that with Joe Stiebrick. So is everybody here familiar with Joe Stiebrick? So he invented he didn't invent building science, but he's the one that he started Building Science Corp. He did invent the blower door test. So that's always a fun story hearing that one. He also tells us that the Canadians gave us vapor. Oh, okay. He also talks about how the Canadians gave us vapor barriers because of the Wayne Gretzky trade. So, and then these are just some other details that are also on there. Roof assemblies when you're using continuous insulation, still a vented system on top. But yeah, and actually right here is also a QR code. If you want to scan that just to download it now, or again, it's on our website. Our website is very nice to work with. And then that's pretty much it that I had. If there's any questions, I know we were kind of fielding questions as we were going, which I love.